a 3-bit Connects computer I built that's based loosely on the Digicomp I design. It's capable of doing a lot of things, including adding, subtracting, multiplying, dividing. Uh, it can do logic problems even, depending on how it's programmed. It's way too complicated for me to explain this whole machine, but as you can see in this picture, there's the orange rods on top, that's the output, and then the gray rods on bottom is the input. And depending on how those are placed, you can use the machine to say things like, if A equals 0, make B 1, or if B and C equals 0, make A 1. When dealing with a computer like this, something really important to know is binary, because the computer only deals in ones and zeros. Now, to read binary, you first look at the row. If it's the first row, you add 4. If it's the second row, you add 2, and if it's the third row, you add 1. So if you have a 1, 1, 0, it's really 4 plus 2 equaling 6. If you have 1, 0, 1, 4 plus 1 equals 5. So the game I'm going to play with my computer it's called NIM. Each player starts at 0, and the player who goes first adds 1 or 2, then the next player adds 1 or 2 on top of that, and the player who says 7 wins. Often you'll find this game played up to 21 or around there, where the player who says 21 wins, or sometimes the player who says 21 loses. But for the case of this computer, it can only count up to 7, so we'll just do it with 7. Alright, so I'm going to show you how the game of NIM works on this computer. First off, if you want to be able to understand everything, you need to know binary, which hopefully you just learned it or you already knew it. So, and second, you need to be able to know what the computer's saying, where we're putting in values, which is right over here. You can see the 3 digits, 1, 2, 3. And when the gray piece is out, away from the machine, it's a 1, and when it's in, it's a 0. So if I put something like that, it's a 101, which is the binary number for 5. If it's like this, 011, that's 3. And for the game of NIM, we always started at 0, so I'm going to leave it there for now, and I'm going to let the machine go first this time, so I guess I'll just run it right now. Alright, so from 0, the machine adds 1 to get to 001, which is the number 1. And I get to add either 1 or 2. I'll probably add 1 to the total, making it 2, which is 010. And now I run the machine again to see what it says. Alright, it answers by adding 2 to get 4, 100. Now I get another choice. I can add 1 or I can add 2, 5 or 6. Either way, I'm probably going to lose because the computer will add 7, right? What if I put 5? There's still the chance it could mess up, right? Okay, computer answers by giving 7. So the computer won that time. Alright. This time I'm going to go first instead of letting the computer go first. That way I'll have a chance. I think I'll start by doing a 1. So I just see what the computer responds with. And it says 010, which is a 2. Now I get to add 1 or 2, so I can do 3 or 4. I'll probably do 3. So again, I run it, and the computer responds by going to 4. Sometimes these things don't go all the way over. Okay, so now I get to add 1 or 2 again. Finish this off. Oh, I can go to 5 or 6. Let's go to 6 this time, just to show. And it finishes by doing 7.